Hi, I'm Adolph Oliver, and this is a video clip about how you can come up with the inverse function if you have a graph of the original function. Okay, well, here's an example down here. Just let's mention what we're doing. Let's say you're given this graph line here, okay? And what you do is simply go through and do this. You set yourself up a table of values over here, and this is a linear graph line here, so we only really need 3 points. So I just arbitrarily picked 3 that I could tell the values on. You could use other points, but x equals -2, y equals -5, there's that one. X equals 0, y equals -3, there's that one. And x equals 2 and y equals -1. So these 3 points are listed right here, and I just pulled those right off the graph. Well, the key to making this work again is using something we did when we were finding inverses of equations recently. And that is interchanging the x and the y to preserve the independent-dependent relationships. We're going to do that, and then we're going to graph those xy pairs, and we'll find out that the line that we get is going to be symmetric about the line y equals x, about the 45-degree line here. One step at a time. Okay, so anyway, here's the original function right here, the f of x. Okay, now what we want to do is to be able to draw on this graph the inverse function. So here's what you simply do. You say, okay, f -1 of x is going to be these guys. That's the y value. And the x's are going to be these guys. So now replot, but now these are the x's and these are the y's. Works real nice with the table of values like this. So okay, if x is -5, -5 is over here, y is -2, so here we go. There would be my first point. X equals -5, y equals -2. Okay, then I've got x equals -3 and y equals 0. X equals -3 and y equals 0 is right there. Lastly, I have x equals -1 and y equals +2. There it is. Okay, so here we go. This line right here, and we only need 3 points since it happens to be a straight line. This is the f -1 of x. Okay, and notice that if we indicated, let's see if I can sketch this in. All right, here we go. This is the y equals x line, if I can do this well enough. There it is. These guys are mirror images. In other words, this point here, you go the same distance over here, there is the other matching point. Same thing here. So we'll find that these guys are always going to give us the original function and the inverse function as being mirror images along this 45-degree line. So if all you need then is a graph of the inverse function, you can play this game. Again, since we were given the original graph, I just picked 3 points, and then what I said is okay, I change it around, so the first column here is now f -1 of x, which we normally call y, and the second column is x. Plot those, and there it is. So the original f function and the f -1 of x function. Pretty easy way to work these guys. Okay, here's our first example, and notice What's going on this one here is we were not given a graph of the original guy. We were given a function. So if we want to use this grafting technique, the first thing we have to do is turn around and use, well, a table of values works good for inverting the graphs. So graph this. Notice it's x to the first power, so all we really need is 3 points here to be able to make this work. So let's set up our table of values here to graph this. Here we go, x and then f of x as it's called. Now you're going to get fractions all over the place here, so let's just pick some values that are kind of in the boundary here. So x equals -4, let's say 0, and +4. You could have picked other things, 3, 5. You could even had these different. But you do want to double check that you're going to get the correct functions here. So now, let's look at this. If I have x equals -4, minus x will be +4. +4 minus 4 will be 0. Well, 0 over 5 is just 0. So that would be my f of x for that. Now, if we have x equal to 0, then -0, that's just 0. So I end up with -4 over 5. So -4/5 will be my graph value. And then the guy on the end here, the +4, well, if I put +4 into x, the minus will make it -4. -4 minus another 4 is -8. So -8 over 5. And to graph this, it'd be easier to write it as a mixed number, -1 and 3/5. Okay, so there we go. Let's graph the original guy up now. X equals -4. 1, 2, 3, 4, and the f of x, or remember this is the same as the y here, is 0, so there it is. Okay, and then x equals 0, y equals -4/5. Well, x equals 0 here, -4/5 is not quite to -1, so about there. Okay, and then x equals +4, 1, 2, 3, 4. Y is -1 and 3/5, so -1 and 3/5, just a little bit past halfway. So there we go. Okay, so I draw up. See if I can draw my line a little better here. Here it comes. Okay. So this would be the f of x. So the additional step here is we had to make the table of values to get the original graph line. Sometimes you'll be given this graph line. Sometimes you'll have to do this. Well, now the rest of it's simple. Remember, we interchange this. So the f -1 of x will be these guys, and the x's will be these guys. So let's now plot them. Okay, x equals 0, the y is -4. So if x equals 0, okay, right here the y is -1, 2, 3, 4. Here we go, it's right here. Okay, x equals 0, y equals -4. Then x equals -4/5, y is 0. Well, x equals -4/5, it's just a little bit over here, and y equals 0, okay, is going to be right about here. Now let's make sure we got that right. X equals -4/5, okay, less than -1. Y is 0, okay, looks good. Now, the last one here, x equals -1 and 3/5. Well, 1 and 3/5 is going to be, about a little over halfway there. And we want y to be +4. 1, 2, 3, 4. So it's going to be upward right about like this. Okay, well, this has got to fall in a straight line, and it sure, looks like it within my fancy grafting here. If you want to be a little bit better, you get a ruler out or something. But anyway, here we go. F negative 1 of x. Okay, so here was the original f of x. We used the table of values to get it from the function. Then, since all we wanted was the graph of the inverse, we play our game of interchanging the x and y's, and the y, of course, f negative 1 of x, and plot it. Now remember again, here's the idea. These guys are mirror images across the 45-degree line. So these points are opposite, these points are opposite, and those are. That's just a little something you notice when you do these guys. Okay. Okay, here's another example. And this is a case again where we're not given the original graph. We have to make it ourselves, so that's not impossible to do, just a little extra work. So g of x equals the quantity x minus 1 cubed plus 1. Well, this cubed, if this quantity gets large, it'll be way off the graph here. So you're going to want to pick numbers that are fairly close to the origin here. So let's turn around here and set up our t-chart. Now the other thing, of course, is this is not going to be a straight line. So we should take some extra points. So here we go, and this will be g of x. Okay, so, it's kind of your choice. Take some simple things, minus 1, 0, 1. See, we're subtracting 1 from it, so that's why I'm going to bias myself a little bit more toward the positive x's here. Even this last one I think is going to be off the graph. But anyway, now let's come up with the values that we have here. Okay, if x is negative 1, then negative 1 and negative 1 give me negative 2. Negative 2 cubed, 2, 4, 8 is cubed. There's odd number of minuses, so it's going to be negative 8 plus 1, negative 7. Okay, x equals 0. I've got negative 1. Now I cube negative 1. It'll be 1, but negative 1 because we got 3 minuses. Negative 1 plus 1, well, that's going to be 0. Okay. 1. If x equals 1, 1 minus 1 is 0. So we cube 0, we get 0. So that's just going to be plus 1. 2. 2 minus 1 gives me 1. I cube 1. Well, that's 1, and it's positive, so it stays that way. And then so plus 1, add more 1, we get 2. Okay, now 3. 3 minus 1 gives me 2. Okay, so 2 cubed is 8. Plus 1 more, looks like we got 9. Okay, let's plot these guys up and see what happens. Some of these points are going to be off the edge of the graph. We'll have to extend it a little bit. So x equals negative 1 and y, g of x equals negative 7. Well, this goes down to negative, let's see here, there's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. I'll say negative 7 is about there. Extend the graph a little bit. Okay, this next one's easy. 0, 0 is just the origin. In fact, the next couple guys are easy. 1, 1 is right here. And 2, 2 is, let's see, 2 over here and 2 up here is right here. Okay, then when we go to x equals 3, we're up to 9. Well, this is 6, so 7, 8, 9 would probably be up here someplace. Now, since this is a cube, okay, it's going to have two bends to it, and all that bending is occurring right here. So this thing's going to look like this. Coming up here, bending here, bending back up, and on up it goes. Okay, and the reason we know that is that cubes always have two curves in them, so the curves have to be right here. Okay, well, this is the g of x guy. Okay, now we've done all the work here, because now g negative 1 of x, our old y, is going to be the first column, and the x's are going to be the second column here. So let's go and plot these guys up. X equals negative 1, and x equals negative 7. Remember, we're coming from the bottom here. X equals negative 7, y equals negative 1. Well, negative 7 for x is going to be over here. Y equals negative 1. Looks like it's right about there. Okay, let's see, negative 1. I'm a little bit low. About there, okay. Now, 0, 0, well, that's easy. The same thing here, so there that is again. And x equals 1, and y equals 1. That's the same guy right here. And then x equals 2 and y equals 2. Well, that's the same guy right here. And then x equals 9, so we got 6, 7, 8, 9, and y then has to equal, what do we got here? 3. So y equals 3, so go up 1, 2, 3. It'd be right about there. Okay, well, this is also going to have two curves to it. So it's going to curve here, but in the opposite way. So here it comes. We're coming over, hitting this guy. Okay. And then we're going to curve up, hit this guy, and then we're going to go over and hit this point up here. Here we go. This is going to be our g of negative 1 of x. Now, you don't have to get these graphs perfect, we're just roughing them in to see what's happening here. You don't have to make yours any fancier than mine. If you really want it perfect, that's when you go get your graphing calculator, but that's for future classes. So, okay, so here we go. The 45-degree line here is going to be right through here. Here it goes. And so you can see that these guys are mirror images here. These guys up here are mirror images, same distance in opposite directions. And these guys here are right on the 45-degree line. But anyway, there it is. This is the original function, g of x, and this is the inverse, g negative 1 of x. And if you wanted to see the graph, here's how you do it. Graph the original guy, interchange the x and y roles here, replot it, and there is your function that's the inverse. Well, okay, here's one last example of this grafting technique. And remember again, you'd only be doing this if you were required to come up with the graph of the inverse function. The easiest way to do it is to graph the regular function and then just play the swap the variables routine and replot. Well, here we go. This one here again, x to the fifth power here. So we're going to end up with values that are going to be beyond what we can do here. I don't think all of these will be able to plot. But anyway, what I did, since we're subtracting something here, is I biased this a little bit toward the positive side. Let's see how it works. So if the x is 0, then what we have here is negative 2. Negative 2 to the 5th power. Well, there are 5 minus signs, so that's negative. 2 to the 5th is 32, so this would be negative 32, but the minus in front makes it positive 32. Okay, x equals plus 1. Plus 1 minus 2 is negative 1. Well, again, 5 minus signs, so it's negative, so 1 to the 5th power is just 1, so negative 1, but then the minus in front makes it positive 1. Let's indicate that these guys are positive here. Okay. Now, x equals 2. 2 minus 2 is 0. So 0 to any power is 0. Minus 0, well, that's just plain 0. You can write plus or minus, whatever you want. Okay, now, x equals 3. 3 minus 2 gives me positive 1. Positive 1 to the 5th power is just 1, so the negative in front makes it negative 1. And then this 4 I think is going to be too large again. Let's see. 4 minus 2 is positive 2. Yeah, 2 to the 5th is 32. The minus in front makes it negative 32. So the first and last values we have here, way off our graph here. We're going to have to go basically with the guys in between here. So here we go. X equals plus 1, y equals plus 1. So x equals plus 1, y equals plus 1. X equals plus 2. Okay, y equals 0. And x equals 3. Y equals negative 1. So 1, 2, 3, negative 1 right here. Now, let's kind of indicate what happens with these other guys. At x equals plus 0, we're at plus 32, which is way in the devil up here. And at x equals plus 4, we're at negative 32, which is way in the devil down there. So that gives us some guidance as to what to do here in working this guy up. So here we go. Again, 5th power. Okay, we're going to have curves in this thing. So here we go. It could look like this. Coming down from way up here. Oops. Coming over. Going through here, coming down, and down it goes. Okay, so this is roughly what the g of x looks like. Okay, now the rest of it's easy here, although we're going to be off the graph again in places. This is going to be g negative 1 of x. Remember, we interchanged the roles here, and this is the x here. The g negative 1 of x, of course, is just our old y. So, let's see how we do here. At x equals 32, which is way over to the right, y equals 0. So, here we are. I just put an arrow over here and say, way over there someplace. Okay, at x equals 1, we get y equals positive 1. So, at x equals 1, y equals positive 1. That's this guy right here. Okay. At x equals 0, we've got y equal plus 2. So x equals 0. Y equals plus 2 is right there. And then at x equals negative 1, we got y at positive 3. 1, 2, 3. There it is. And then, of course, at x equals negative 32, which is way off to the left, we're going to have y equals negative 4. So this is going to head to negative 4 way over there, just like this one headed to 0 way over to the right. But it gives us an idea here of how to help continuing to match these up. Okay, so remember then our good values here were 1, 1, 2, 0. In other words, these 3 points and the distances. So it's going to look something like this. Coming in, hitting this guy, coming down here, coming over here, and going out and hitting this guy way out this way. Okay, there's our rough sketch of g of -1 of x. Okay, well, once again, these guys are mirror images around this. These two match each other, these two, and so on. So, again, what we did here is we used the original function. We picked some x values, and some of the results we got were beyond the edge, but we just indicated where off they were so we knew how to draw the lines. And we got the original function, g of x. Then we interchanged the x and y's, okay, and replotted, and then we got the inverse function, g -1 of x. Okay, so once again, if you're after the graph of the inverse function, this is a nice way of being able to do it.